Good evening, all. I'm Madhvi, and I will be presenting remediation of arsenic 3 ions from water using graphene-based materials. As well, the different contents of this slide are given below. That is, I will be introducing what are the different sources, what is its current status in India, health hazards, then different graphenes used till date, and what is the conclusion. So arsenic is the ranks 20th in the natural elements that is causing problem and is in the group 15 of the periodic table. It is very hard and crystalline solid with a silver gray color. It is found in the environment both in organic and inorganic form, but inorganic form is considered the more toxic one and is causing problem at a large scale and is causing health hazards also. So there are different reports from different countries has been collected, and it has been found that it is affected India, US, and other countries too. And the level of arsenic in India is too much. So the increased arsenic is causing the toxicity of arsenic is causing is very problematic in humans and is causing even cancer also. So once the arsenic enters into the food chain, that is the water is being affiliated from the industries, as arsenic is being used in paint industry, chemical industry, and when the water is disposed of in the sea without prior treatment, the effluent affects the water, and hence once it enters into the food chain, it is causing a various type of health hazards. So WHO has recommended a limit of arsenic in drinking water, that is 10 micrograms per liter or 10 ppm. So the sources of arsenic in contamination in water, it can be natural as well as anthropogenic. That is, there are a number of arsenic, rocks that are rich in arsenic, so they cause leaching of the arsenic in the groundwater. Volcanic eruption is causing percolation of arsenic in soil leaching, and anthropogenic is the use of agrochemicals uh, in fields, melting of non-ferrous metals, wood preservatives, these industrial sources, and burning of fossil fuels, and many more. So it has caused a number of health effects as it has entered into the food chain and is causing cancer in skin, lung, bladder, kidney, causing skin damage. Reproductive health effect is being affected. Then blood cell reproduction is affected, liver enlargement, and number of neurological disorders have been claimed, and it also causes cardiovascular diseases. Arsenic contamination in India, it has affected India widely, and it has its effect in West Bengal, Jharkhand, Bihar, Punjab, Uttar Pradesh, Assam, and many regions of Haryana too. This study has been collected from in March 2018, that it has affected 12 or 17 districts in Bihar, and the level of arsenic is above the permissible limit, which has causes cancer in number of people who are being exposed or who have been drinking that water. Then a study was conducted in 2020. Many million people have been globally at risk, and there are some name of some countries like Kalagam, and you have this Bhojpur and Vishali district where the parts per billion of arsenic concentration is above the level and is causing many problems. So Water Resource Ministry has also done its work, and it has been found that 65% of the Assam population, 60% of the Bihar, and 44% of the Bengal, and 25.4% of the Punjab is affected by arsenic drinking water. So various reports have been collected. So it is very important. No doubt, the government is taking into consideration these things, and there were a number of conventional methods that are being used. That is coagulation, flocculation, adsorption, and many more methods have been used. But since these methods were not effective because of their expense or because of their efficiency, so there was a need of different methods that can be used so that we can overcome the problem of more arsenic in water, and the local person or the poor man can also be helped with that. So there are graphene based materials. They act as an excellent adsorption characteristics because of their higher stability, large surface area, and higher strength. They cause the removal of the contaminants from water, and their removal is totally dependent upon the nature of the contaminant. So various methods, I don't know why the pictures are not coming. 1 minute. Are you able to see the figures? Excuse me, sir. Excuse me, sir.
Yeah, hello.
Hanji, sir, are you able to see the figures?
No, you are talking, you are studying, you are reading the various techniques applied for
Yeah, but there
synthesis.
was some picture, so I
Yes,
want
no, we can't see it.
you can see. Okay, so there are various techniques for the synthesis of the graphene-based material that has been used, that is being used, and the picture. 1 minute. So various methods are used that has been used for the removal of this arsenic, and well, the graphene-based materials which were used as nanoadsorbents are highly dependent upon what factors we are taking into consideration. That how much of the arsenic can be absorbed. That is totally dependent upon all the various factors. That is the concentration of the solution, temperature at which we are carrying out the adsorption process, pH of the solution, ionic strength, adsorbent modification method, how we have modified the graphene material, then what adsorbent we are taking, what is the chemical nature and physical properties. We have graphene oxide, we have composite graphene oxide and reduced graphene oxide have been used because of their surface area and selectivity in contaminants. This is the various studies that has been done. This is the various study that has been done, like chromium oxide, I don't know. So these are the various studies that has been taken into consideration at various temperatures and at various pH, and they have shown their adsorption capacity. That is, the adsorption capacity of 84.89 has been shown. Then it is the Fe3O4, it has shown 34.85 capacity. Then I have graphene coated iron oxide, which is showing capacity of removal of arsenic 3, 65 mg per gram at a temperature of 298 and at a pH of 6 when the adsorbent dose, that is graphene coated iron oxide, was used of approximately 10 mg per liter. Then we are using Fe3O4 and copper oxide and graphene oxide for the removal of arsenic 5, and arsenic 3 also removal was carried out and the adsorption capacity was below 70. Similarly, we use nanohybrids and they are able to remove both arsenic 5 and arsenic 3 with a capacity of 306 mg per gram and 431 mg per gram for arsenic 5 removal. So the conclusion is that various methods are used for the synthesis, and the outcome is that 7 at PS7 graphene oxide iron nanohybrid worked well for arsenic 3 removal at pH7. Then we have composite chitosan mono nano composite that has been used for remediation of arsenic 3 ions and was widely effective at a pH of 3 to 10 and absorption capacity of 289.42 mg per gram at a pH of 3. The number of heat we are able to regenerate them excellently within 3 cycles. So graphene is an expensive material, but the derivatives have a very large surface area, so cheaper and and can be easily used. Then practically, this method is used because it does not create any limitation as it is synthesized by a green method, and many innovative progressions are being used by scientists at Rice University Lab to convert the bulk quantities of carbon-based material into graphene flakes so that we can use it economically and there should be no expense also. So adsorption studies should be conducted using graphene-based materials via green synthesis in order to avoid the use of hazardous chemicals for adsorption also. And their excellent adsorption capacity encourage us for their possible removal of arsenic. So these are the references that I used for my study. Thank you so much.
Thank you very much. Is this your conceptual review paper?
Yes, sir.
Okay. Because you in your title, you have to mention like the redemption of the arsenic ion from water using graphene-based material.
Yes, sir.
So, since it's just based on the secondary data, based on the literature review, so you have to mention in the title.
Okay, sir.
Okay,
Anji.
that's my comments on.
Okay, sir.
Thank you.
Thank you, sir.